Okay, I want to say something here before I go on to chapter 18, alright? Now, I want you to take note of this. When I integrate from A to B, right? This is actually the integrated function. Then BA, I will have FB minus FA, agree? Oh, this is what we have. Okay? Alright, now I want you to take a look at this. Okay? Alright? Can you see this? Okay, all of you look up. This will be the negative of so this will be what? Negative of FA minus FB, which means this will be FB minus FB, right? Can you see they are the same? Can you see they are the same? Okay, so what is the moral story? Because some textbook will tell you this. If I integrate from A to B, fx dx, it's the same as when I integrate negative of what? B to A, right? You flip the thing. It's okay. This is the proof. Do you understand it's actually the same? Can you see what I'm talking about? Okay, BA, so I BA first. Then after that, negative of AB. So I AB, after that I flip again. Can you see what I'm talking about? They are actually the same. Everybody okay? Can or not? Can, huh? So, let me just double check. AB. Okay. Okay, good. So this is what I want you to take note of. Everybody okay, Ken? Can, huh? Okay, no problem. Okay, now, next thing, chapter 18. We're going to talk about kinematics, okay? Now, as I said, it doesn't mean that those who do physics will be better off than us, okay? Alright, some who do physics will still fail this particular topic. It doesn't matter, okay? But we must know of something. What is a scalar? I told you already. A scalar only has magnitude when I did vectors, right now. Vectors have what? Magnitude as well as what? Direction. Okay, now in kinematics, let's say this is the original position. We always take this position as what? Positive, this direction, and this direction as what? Negative. Understand? So if you move this direction is positive, if you move the other direction is negative. Okay? Now, then I need to talk about something that is important here. What we mean by displacement. Can you all of you take a look at page 145? Page 145, please. Displacement. The displacement of a particle is defined as the change in position of the particle with respect to a fixed point at a particular instant. It has both magnitude and direction. Displacement can be positive, zero, or negative. Okay? Now, we don't have to do the activity. Okay, now let me just tell you what it means here. What's the difference between displacement and distance? Okay, now all of you look up. Let's say a particle starts to move from here. Okay? Now, if the particle moves until 3 meters, let's say this all is meters. Here, then go here. Let's say this is negative 3. I will say the displacement is negative 3 meters now. Because it's in that direction. Negative 3. With respect to O, it's over here. Okay? But if the particle moves like that, right? This is called the displacement. Can you see there's a magnitude and there's a direction? Okay. Now, what about if I want to know the distance traveled by the particle? Is it negative 3? Distance traveled is the absolute distance that is traveling. Can you see 3? 3 again, right? How many already? 6. Then 3 again. So actually the distance traveled is 9 meters. Do you understand what I'm talking about? Displacement is with respect to a particular point, the starting point. Okay, distance is you don't care, you just total up everything. Everybody clear? Can or cannot? Can, huh? Okay, now let's take a look at the bottom of page 145. For a particle moving in a straight line, given that S is the displacement of the particle from a fixed point O, if S is bigger than 0, the points at the point along the positive S-axis. Can you see? Outside. Okay? If S is 0, that means it's at the fixed point. That means no movement. Then if S is less than 0, it's a point on the negative S-axis. Are you okay? Now, in kinematics, right? Displacement is usually denoted by S. Understand? Yes or no? Yes, huh? Okay, good. So, that is the first part of the definition. Okay, so I'm going on to the second part. Huh? Turn to the next page. What do you mean by velocity? Now, the scalar part of velocity is actually speed. You understand speed? Okay, now, I think you learned in your Emacs last year, right? I don't know how much you can remember from last year. Wait, let me organize my things first. I don't know why is it in a mess. It's very terrible. Wait, this is too much. I cannot take the mess here. Wait, I organize my things first. Then after that, I take out my chapter 18. Okay. This is my chapter 17. This is my chapter 18. Very good. So my 18 is here. Okay, don't talk, huh? Don't talk. Okay, let's look at velocity on page 146. All of you look at velocity. Hello? Velocity is the rate of change of displacement. That means velocity is also a vector. Can you see it? If displacement is a vector, rate of change of a vector is a vector, am I right? Agree? Okay, now let's take a look. The velocity v of a particle moving in a straight line is defined as v is ds dt, where s is the displacement of the particle, moving particle at time t. What do you mean by that? If I want to find velocity, I will differentiate displacement. Understand? I will differentiate displacement. That means when I go, can you remember last year when you did distance time graph? Distance time graph. If you want to find speed, you find the gradient of the distance time, right? It's the same, huh? Find gradient, it means you differentiate, right? Okay, what if it's a speed time graph? How do I find acceleration? You find the gradient of the speed time graph, right? That will be the acceleration, agree? Okay? So, let's take a look at the next page, please. Page 147, all of you. In general, we have the following. For a particle moving in a straight line with velocity v, if v is bigger than 0, that means if v is positive, the particle moves in the direction of the positive s-axis. That means to the right for horizontal motion. Understand? Move like that, this way, to the right. Okay? If v is 0, means the particle is at instantaneous rest. That means when v is 0, the particle is at rest. Understand? Okay? If v is less than 0, the particle moves in the direction of the negative s-axis. That means to the left for horizontal movement. That means here, to the left. Everybody clear? Okay. Now, I'm not going to stop here yet. Okay. I don't want to go to example 1 first. Can we look at the next page, page 148? I want to talk about acceleration. There are only 3 things: displacement, velocity, acceleration. That's it. The end. Okay? Now, can we look at acceleration? Acceleration is the rate of change of velocity. The acceleration A of a particle moving in a straight line is defined as A is dv dt or d2s dt square, where s and v are respectively the displacement and velocity of the moving particle at the time t. Now, what do we mean by that? If I want acceleration, it will be, now, this is s, right? This one is v, right? You will differentiate v. If I differentiate v, that means I differentiate the displacement 2 times, that's why it's d2s dt squared. Everybody clear? Everybody clear? I'm going to write on the board. This one is Yeah. Look, velocity is V, and V is when you differentiate the displacement. Everybody okay? Then acceleration is A, is when you differentiate the velocity. Now, can you see that if I differentiate velocity, it's actually d2s dt squared? Because I differentiate, then I differentiate again. Understand what I'm talking about? So this one is equivalent to d2s dt squared. Okay? Now, then I want to go for the follow. If from here, I differentiate, right? What if I'm given acceleration, I want to find velocity? I integrate. What if I'm given velocity, I want to find displacement? I integrate. So that's the logic. Understand? This way you differentiate, the other way you integrate. That's all. Understand? Okay? Now, before I continue, can we look at page 149? There's still some more things for you to read. In general, we have the following. For a particle moving in a straight line with acceleration A, I think this 4 is mad. No, this is atrocious in my opinion. Wait, I still got how much time? 1, 2, 3. Still got 15 minutes. First, no, you must listen to me. I'm very upset with this. Can I keep this one for a while? First, keep this keep with you. First, they call nuggies. Nuggies is an element of 403. Then they call the universal set, which is 403. You understand? I don't know what they're going to call next though. What is bigger than 403? Set 4 cohort. Right, now it's even bigger. I'm about to say that. You see? This is the universal set. Let me revise. Universal set, this is set 4 cohort. This is 403. Oh, disjoint. There are actually 9 classes. Because you cannot belong to 403 and 4Y at the same time. So let me show you. You must be like this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 4 to 4, 9. Then after that, nuggies is just one thing here. One element here. Do you understand? All of them are disjoint sets. Agree? Yes. This is called revision for set. Do you understand? And this one is a weird class. Am I right? This class is weird because they keep shouting outside my class for no reason. And when I look out, right, I can see the thing called silence. Can you see it? But how about music? So scary, right? Huh? That's what?
Like Minecraft, like you log in and there's a
I don't understand what's that.
Minecraft is a game.
Sorry, I don't know what game. I never played it. I told you I played the game only one. The Candy Crush, that kind of game, right? Okay, you see, when I look out, I can see silence. Lesson in progress, that kind of thing. Now after that, nuggies. 403. Now after that, they call me, say, right, I already walk out. I said, why are you calling me when I'm teaching? It's so rude. And can you please look at the sign, repeat 10 times. What is it? Silence. Okay, now, see, interrupt me until I'm ready. Page 149, right? In general, we have the following. For a particle moving a straight line with acceleration A, if A is bigger than 0, that means the particle is speeding up, right? Accelerates. If A is equal to 0, that means the particle is moving with constant velocity. It's not stopping, it's just that the velocity is constant. Everybody clear? Now what if A is less than 0? That means the particle is slowing down or decelerates. Everybody clear now? Can or cannot? Can. So these are just some definitions for you. Okay, now I shall ignore. I'll tell you something first. If they shout again, right, I'm going to go and shout and then I shout, okay? This is called an eye for an eye, a tooth for a tooth, a shot for a shot. Okay, I don't care. Alright, now let's take a look at example 1, page 147. Today no homework. Don't yay, today no homework means what? Got a lot of homework. Very good. You have well trained nowadays. Very good. I like this kind of attitude. Very good. Okay. Let's look at example 1. Okay. Let's look at example 1. Okay. part already. This is important. Because kinematics, usually people have problems. Understand? They apply the wrong concept. Huh? Are we ready over there? You want to still laugh at 4, I can give you 1 second to laugh. Then after that, I will continue. Okay? Now, example 1, page 147. A particle moves in a straight line so that t seconds after passing a point O, its displacement s meters is given by this. That means this is the formula for the displacement. After passing a point what? O. Understand what I'm talking about? Okay? This is the displacement. Okay. Find the value of t when the particle first comes to instantaneous rest. Now, I must say this. When the particle comes to instantaneous rest means velocity is what? 0. When the particle is at rest, velocity is 0. Okay, now, I don't want to differentiate like that. I want to expand this out first. Okay. Yes or no? Then I expand this t squared minus 12t. Something wrong with this is t squared. So this is t cubed plus 36 t, right? Alright. Of course, you say you want to use product rule is also okay. It doesn't matter. So what is ds dt? This one represents velocity, right? So I'm going to differentiate. This is 3t squared minus 24t plus 36. Everybody clear? Okay? When it's an instantaneous rest, what is 0? When v is 0. Okay? I will have 3t squared minus 24t plus 36 equals to 0. Can you see I can divide throughout by 3? So I'll have t squared minus 8t plus 12 equals to 0. So I have t, 6 and what? 6 and 2, right? Everybody okay? So what do I have? T minus 6, t minus 2 is 0. So if t is equal to 6 or t is equals to 2. Okay? Now, the question asks, find the value of t when the particle first comes to instantaneous rest. That means when time is 2 seconds, or time is 6 seconds, it will come to rest. So which is the first one? 2 long. Understand? So, when t is equals to 2. Understand what I'm talking about? Now, what is the motion like if I sketch it out? I draw it out. That means, all of you look here please. This particular particle starts from O. Understand? All of you look. When the time is 2, it will stop. That means it will stop and turn. Understand? Once it stops, it must continue moving. So it will stop and turn. What about when t is equals to 6? That means this is when t is equals to 2. Understand? Then it will go until t equals to 6. I don't know where it goes. Then it will turn again. Every time v is 0, it will stop and turn. Everybody clear? When v is 0 means it will stop and turn. Clear? Okay? Alright. Now, are we okay with the first part? First comes to instantaneous rest. Is t equals to 2. Are we okay? Alright, next part. The particle returns to O when t is big T. Find the value of big T. Alright. Now, when it returns to O, the motion starts from O. Hello? Please look up. It moves and then returns. When it returns to O, do you agree displacement is 0? Can you see displacement is 0? Yes or no? So, when S is 0, I will have T. That means I'll have T equals to 0 or T minus 6 equals to 0. T is equals to 6. Am I right to say that? Correct? Now, that means what does it mean? When T is 0, is at O. When T is 6, is also at O. Of course, I cannot take this one by. This is the initial one. Haven't even moved here. Right? Returns to O means T must be what? 6. So, this big T must be equal to 6. Can you see? Everybody okay? Clear so far? Okay, now next part 3. The distance travelled from t equals to 0 to t equals to t. Oh, now. Okay. This is a round, actually quite roundishy, but never mind. Let me just sketch to you what is the meaning here. Okay, all of you look. This guy starts from 0. I say, look at me. Angry. Okay. At t equals to 2, it will turn. Am I right to say that? Alright. Okay. When t equals to 2, what is my s? Am I right? Okay, wait, some people forgot. S is given by this. Correct? Yes or no? So what is this? What is this? Cannot count. 32, right? Oh no. Must think so long, very sad, no? Can you see it's 32? That means all of you look, this is displacement. The particle will start from here, right? Until 32 meters, it will turn. And this is when t is equal to 2. Am I right? Okay? Then it will return to O, right? That means we'll go like that. T equals to 6, right? Alright now. What did the question ask? Distance or displacement? If it's displacement, it's 0, you know. Correct? What about the distance? 32 times 2, Can you see it's 32 times 2? Okay, look at the next page. So it's 32 times 2, 64. Can you see what I'm talking about? Yes or no? Now, if they continue, right, it will just go backwards like that. Understand? Unless they say completely stop, then it will be there. Everybody clear with what I'm saying here? Can or cannot? Can or cannot? So you see, it's not so difficult, right? Okay, I repeat. From displacement, get velocity, differentiate. From velocity, get acceleration, differentiate. Okay? Acceleration, go to velocity, what? Integrate. Velocity, go to displacement, integrate, that's all. Okay? Then, diagram is very important in kinematics. Don't say, I can imagine. Then imagine all the wrong things. Understand? Okay? Alright, stop the video. As from